Good afternoon. I am Andrew Turner. My day job is I'm the CTO of ArcGIS Hub, but I also work on a lot of other R&D activities. I work on, when I joined Esri 12 years ago, Esri had two open source projects, one on CodePlex and the other one on SourceForge, if you remember that. And at that point, we kicked off open source, so I helped do that at Esri. I do a lot of things with a lot of other amazing colleagues, like Emily. You want to introduce yourself? No.
Hi, everyone. I'm Emily Hu. I'm the product manager for the JavaScript team.
So what we want to do this afternoon is give you, as I was saying for a little earlier, for those that were here early, thank you, a little bit of an overture. You saw a lot of amazing things this morning. We want to help pull that apart a little bit, give you ways to start framing your thinking around this, give you pointers to sessions and topics and things like that, and then you're going to ask us lots of questions or go to those sessions and ask them questions, or even best, one of the most unique things about this conference. How many people, this is your first time at Dev Summit? Wow, awesome, cool. The showcase. It's the one place you can talk to all the developers actually building the software. So everyone here that's giving a session is also at the showcase, so it's like the unique one-on-one time we can say, but what about this? And tell me more about that. And I was saying they might even say there's not yet documented features, or if you say something like, okay, I'm gonna go and add that, like right now I can't sleep tonight until I add that for you. So it's the showcase, make the most use of that as possible. So, our overture. So, the way I think about this is, the analogy is, it's like you were just shown some awesome tools and capabilities, and all these amazing Lego bricks were just spilled out in front of you. And you're like, go build something. You're like, these look awesome, but I don't know how they all come together. Like, how do I actually build a rocket ship or a house or a city out of these things? So that's kind of what we're gonna do, is gonna show you how the different Lego pieces come together and how they can work together. And then we also want to show you how it's interoperable and extensible. And you saw this very prominently in a number of different ways this morning around open source and open APIs and standards, is at every level of our system and platform, and the way we have our developers build it and the way our partners build it. And so it's interoperable and extensible. With that one little bit you want to add, that one little bit of render, or that one little new data store you want to do, you can do that and leverage the rest of the platform. So it's interoperable and extensible. We also want to look a little bit inside about how the system works. And I'll preview by saying this is the way in which we build our products is using the exact same things that you have access to. There's nothing special. Hub, as a product, has no special access than anything else. ArcGIS Online provides its own database, but it talks to the same feature services and tiles that you can. There's nothing special. So we build our products using these same things that you can now use as well. So we're going to kind of pull that apart just a little bit too. And then what you want to walk away with here is seeing, okay, I have all these Lego bricks. I can see how they can start stacking up and building things. You can start imagining those things. So again, we're going to give you a framing around how to think about these things. We're going to dive in to the different pieces and the different segments of each parts of the stack. And hopefully from this, you're going to say, wow, it's a lot, but I think how I can think about this. And sessions I'll go to learn more about specific details. So first, I just want to talk about web architecture patterns. And if you've been doing software development or engineering, this will be pretty common, but I just use it to reframe it there. And if you haven't thought about it, it's a really great way to think about it. It's like a three-tiered architecture. So at the bottom, at least the way I draw it, everyone draws it differently, but at the bottom I think about web services and the data. And then we're going to talk about the developer libraries and components that interface with those APIs and data. And then finally, the apps that kind of pull the whole thing together to make it all work. So in our tier, in our stack, is we have all these databases here at the bottom, and we're going to talk about how this gets applied here. So as I mentioned, the database is here at the bottom, and then those are things that you can either use from Esri as hosted services, you can use your own ArcGIS server, or you can even use your own data store, APIs, whatever you want. I'm going to dive into that. So any data store in the world, any API in the world, you'll be able to use in the rest of the architecture and system here. It doesn't have to all be in ArcGIS server or in a feature service. So then above that, we have several different, two products at least, ArcGIS Online, ArcGIS Enterprise, that are the same thing, just deployed differently, that help then organize the content here within the system. And these all get registered. These data services and stores get registered as what we call items. Again, if you've used Portal or GIS, you probably are familiar with this, but just making really clear so we have common terminology. These items are really just, they're metadata records. They're a pointer to the URL. They'll have the title, description, things like that, but they're super powerful because that item is something that you can manage and share independently with different people. We talked about the web map item, and we'll dive into them more later. But these are all items, and these all become just layers. And then they can be used and stitched together in one or many web maps or web scenes. And web maps and web scenes are essentially the same thing. Web maps are just 2D, web scenes are 3D, but they mean the same thing. And those are great ways. Those are, again, think of like a set of bookmarks or pointers to the items as well. And you can add and extend that with Arcade, and that gets stored as an item. So you can start seeing how these are all kind of the same Lego bricks, how they come together. And it's great. This is all part of the web in WebGIS or GeoWeb, is that they're all links, which is really great because it means that they're independently managed, they're very encapsulated and modular, and they're very interchangeable, which is great. So what you do is, again, you have a database, you register as a layer, use that layer in one or many web maps. And again, a layer like census might be in tens of thousands of web maps, right? So these things, this is a simplified diagram. They obviously in the real world get much more spidery, how they're really done. Anyway, so you now have that map that you've made, and you can now use that in a configurable app, and we'll dive into those in a second. And you can just embed that now into like a hub site or your own website or whatever you want. And then when you want to, and you have the acumen and power and funding and drive and time, you can go and build a custom application with our APIs and libraries, and those include web components and widgets. So all of this together is a stack that we're now just want you to think about. We'll pull up again at the end, but this is just the generalized architecture, the conceptual architecture on the left, the logical architecture here on the right to think about these things because we go into them, but it's always important to know like here's the whole map, here's what the whole thing starts looking like when we talk about a web map item or a specific library. You can frame it, it's not one thing by itself, it's just that component that fits into a whole ecosystem in a stack here. So I want to highlight the fact that the importance of the web map and web scene, and I think this morning it was such a great way to illustrate it. Just think of the problem to be solved is I have data and I need to analyze and portray it, and I need to use it in apps. And once I built the app, I don't want to have to change the app every single time I change my data, right? So they're decoupled. And the web map is the way they showed that, right? So Jeremy went and built a map of water regions around Kansas, and it was used in multiple applications. And if he'd gone back at the end, he can go and change one layer, add a layer, remove a layer, change the styling. All the apps automatically get that. They don't have to be recoded. It's like amazing, right? It's declarative programming rather than imperative programming. The programming didn't say layer 1, 2, 3. It said just the web map, whatever's in the web map. And so the web map and web scenes are really, really, really important. And they're a really good pattern that I don't see much in many other platforms out there in the world. So that's what we're highlighting is like this core technology and capability that you have. So what they are, technically, they're JSON. It's really simple. They're JSON. They're JSON with a very strict JSON schema, with JSON schema encoding of what they mean. It's how we build, again, all of ArcGIS is by passing web maps around. And inside web maps, they have all these capabilities. I think the list is probably actually like 10 times as long, right? This is just an example of a web map marks up all of these things. It says I have a layer and it's in this URL or it's in this feature service. Here's the styling of it. Here are the attributes of it. Here's the 3D model of it. Here's the symbology and the layers and aggregation and all these other things there. Now, they're authored mostly in the online or enterprise map viewer, the scene viewer, Pro, but you can programmatically build them with JavaScript or Python or Ruby or whatever you want because they're JSON and we have tools to help you do that. So you might have use cases where you actually programmatically build a web map based on some event that happens in the world or some survey response or some automation or generative AI that might create a web map for you. So the nice thing is while we have these very easy to use visual editors for them, you can build them on your own, and as long as you follow the same spec and schema, they'll work everywhere web maps work, which is in all of the apps and things I'm about to show you. So, and again, then that JSON that's under the scenes, behind the scenes, gets rendered in a player like the JavaScript SDK or in Leaflet and other libraries we'll go through. So that's obviously what you see and interact with. But behind the scenes, if you look in the matrix, it's JSON, and it's really, really capable and really powerful. Fortunately, you should never have to write by hand JSON, but you could. But again, we'd advise against it because it's a lot of things to track, and you can get it wrong. Your JSON isn't valid and doesn't work, and it's frustrating. So using our tools and libraries make that really easy. So the other extensions, so web maps have been around for 15 or so or years or more. The more recent, in the last, I'll say 5 or 6 years, has been Arcade. Get it? Arcade. So it helps you by extending and providing not just the declarative formatting of your layers and style, but now you can add behavior and actions to it. So it's a way to essentially think about embedding programming into your web map. It's also safe and means it can't have a security vulnerability, or it's performant and it's not going to all of a sudden take down everybody's machine in your server. So Arcade is a great way that's supported across more and more of our applications that allows you to embed really interesting behaviors and styling and algorithms and math that can be processed in our players in your web maps. And we'll come more into that in a little bit. So we're going to start now and come from the top back down, right? So we gave you that stack. We're going to say, OK, the first thing you probably want to do is you want to build an app. And it might be you have to build an app, and if you get bored by our talking, you can build an app right now. You could probably build 10 apps in the next 50 minutes. So it's super easy. Instant Apps, for example, we'll talk about, is actually its mission is to be able to design and launch an app in less than 5 minutes as you're walking into a board meeting or a conference presentation. It's meant to be, when we say instant, we mean 5 minutes or less. And it can get obviously more detailed. So as we heard before, the question was asked, is like, which app do I use when? So, well, it depends. There's no best. There's a spectrum. So in the furthest left is these no-code configurable apps. Again, Instant Apps is one of the great examples of these things, right? Click a few buttons, you have an app. You have an app which used to be like a whole company in the past. Now it's like, I had 5 minutes, I made an app. It's now like a trash finder, or it's a bird species finder, or a router, or things like that. So these are these no-code apps. And then you have what we call low-code apps. So these are where it's mostly click and configure, but you can do a little bit of coding, you can extend it, you can add some little behavior or widget or a component if you wanted to. And then on the far right are these custom development. You have some brilliant, like world-changing idea, and it needs to do and act very special. You can build those. But the really nice thing, it's a spectrum. You can start on one and smoothly move across and back and forth. You don't have to like choose one and that's it, and you'd go back to scratch to do the next one, because we build our no-code apps the same way you would build a custom app, and vice versa. So diving into these a little bit, and the spectrum is, again, the no-code apps. They're for focused, streamlined apps. They're kind of out of the box. They look that way. You have a lot of configuration options, but you can't say, well, but I want, when you click this button, the whole world to spin 40 times, right? It's like, nope, it does this thing. That's what it's for. So no or minimal configure coding. And then again, on the far right, while it's custom, it takes time. Maybe you can do it in an hour because you're amazing. Maybe it takes you 10 days to do that. Maybe it takes you 4 years and 40 developers because it's a really hard problem. So you have to obviously think ahead about what's the level of effort you can spend on something to the level of customization. And that's what I would say is kind of where you start, which is my advice almost is always start at the left. Prototype. It's like the equivalent of whiteboarding, but in actual code with the real data, which makes all the difference. Like, I don't know, I drew the picture on the board, it looked easy. Well, yeah, but all of a sudden you had a layer where it had 4 million features in it, and that's just, maybe it was slow to load, but also it was a weird interaction. So you can play very, very fast with an instant app. You can build 10 instant apps. Put that in front of user testing, in front of stakeholders, in front of customers, and saying, which of these do you like best? What about them? So by the time you are doing minimal coding or custom development, you've already dialed in the usability and the design, the performance, and you can say, okay, you're doing the design, you're doing the coding, you're doing the data, and they'll all work back together because you just prototyped the whole stack entirely with configurable apps. So the way they work when we talk about the configurable apps, on the left are these story maps, instant apps. Those are both like super easy to use, super compelling, probably solve 90% of what people want is like, I need a little bit of data, which the magic was probably in the data, but now a little of experience to say, well, I need to search by an address and see a list of them and what's nearby. Story maps is great because, like, you know, who doesn't like things like New York Times interactive graphics, except we don't all have huge journalist teams, right? So story maps let you just in a few minutes make a data-driven narrative that really can change people's feelings and mind understanding of what's going on about something. Then we have dashboards, which if you, unfortunately, were around for the last few years for COVID, you probably saw many of these, but these drag and droppable dashboards that are used originally in emergency operations centers, but are now increasingly used for dashboards and actually interactive applications for all kinds of really cool things. And then a little bit kind of getting over a little more complicated because it does more survey 1, 2, 3, right? But you can launch a survey form in just a few minutes that gathers data and questions. It can be a simple yes, no, or voting poll. It can be an 8-page configurable application that gathers up photography that's automatically processed with GeoAI to then send out alerts and things like that. So survey 1, 2, 3 starts crossing into like, it's all no code, but you can start doing some really cool things if you do a little bit of coding. Builders, right? The experience builder kind of really fits this very well in the middle. So the experience builder is kind of like, you know, I want to do some really interesting advanced configurations. So you go into experience builder, and you can start building multi-page configurable applications that let people, you know, zoom and see, okay, a map of all my properties. If I click on one, it has a property page, and then inside of that, I can show a timeline. You can do all that no coding. But then Experience Builder also does allow you to build your own widgets, your own GMU widgets that you can then say, well, I need just one block to do one thing. I need that little spinner or clock thing. Well, you can build that one little component, and then you can embed it into Experience Builder in the Developer Edition and deploy it, and you have 90% configured off the shelf. Esri supports it. If it breaks, it's our responsibility to fix code, and you have that one little widget that's your magic that you want to add to it, and you can do that, right? And again, you can play and use all the Experience Builder functionality with that one little custom component. And on the far right now are these SDKs, right? So we'll dive into this more, these web components, UI components, all these other things that's like, okay, not just Lego, but almost Play-Doh. I can build all kinds of things with it. So with that, I'm going to hand off. Emily's going to start walking through some of the details of some of these configurable apps.
Yes, so as Andrew said, thank you, first of all. I'm going to walk through the details about the configurable apps and just show some quick visuals as well. So as he said, there's so many options for the configurable apps. Oops, it's not connected to me.
Sorry.
Okay, yes. So we have so many options to do them, like Instant Apps, Dashboard, StoryMaps. They can save you time and money, and they can showcase your data. They are designed to create beautiful dashboards or tell a beautiful story just in a snap. So first of all, and of course, it's all start with a web map. Once you author the web map, you can bring it into all the apps very easily. And it's not just the map itself. You can also save the charts you want to do, and also like the related filters with effects. You can all save it in the web map and then bring it to all the applications. So first, Instant Apps, as Andrew mentioned, is designed to create a quick web map within 5 minutes. So we have hundreds, a lot of templates to choose from. And these are for you to hook up to, with the right template, you can create your app for your use case with your own data. And the best thing is it works great both for desktop and also great support on mobile too. And this is like one of the examples of how many templates we have. You can create like a zoning lookup. You can create a quick atlas. These are all like available at a fingertip. And just bringing your web map, you can have a beautiful interactive application. The next up is dashboards. As it says, it can create dashboards for you. It enables you to convey information by presenting location-based analytics using intuitive and interactive data visualization, and everything just on this one single screen. And it can be map-centered, or if you want, you can have the map just on the little corner like this. And if you want to showcase the charts, like the counts, and as this part has the directions, to just map doesn't need to be the center part of it. It's just, you can create the experience as you want. And again, like dashboards, same as Instant Apps, they're great for desktop and mobile as well. We're designing for all kinds of scenarios. And next one, StoryMaps. That's one of my favorite. And there's this beautiful Welcome to Palm Springs StoryMaps created. This is a great way for digital storytelling. It can help you explore locations, events, and trends that matters, and can help you tell remarkable stories using your data, using your map, and to inform people and inspire people. This is a map about the diverse Prague. So it talks about the landscape of Prague throughout the years. And we have a lot of widgets and templates that can help you build this interactive experience for your visual storytelling. Oh, and also, by the way, like at the upper right corner, if you want to know more about any of the product, we have the session recommendation. And there's a lot of session recommendations throughout our sessions. And for Survey 123, it's a great way to build forms for better decision. The data you collected from Survey 123 will be fed into the feature layer. And then with that information, you can present it in your web map and also other web applications.
Yes, I just want to highlight this one because it's kind of like, it's one where you start expanding your thinking, as Emily was just saying on the right. So this was a project we did, a prototype with the Baltimore school district. So again, the survey form was something that was internal only. So school administrator, teachers could report every morning, number of absenteeisms, tardies, other issues to the survey, and it went into this protected feature service. that was only accessible within the school. But then they created a view of that that aggregated that up and went into a public-facing dashboard for transparency purposes. And that would share out the trend over time over all schools, and if they wanted, they could do it by school without revealing any personal information of what was going on in the schools to get kids to show up and prevent truancy, which is increasing in crime and all kinds of things. It was great because they had the equivalent of like this dynamic form capture with an updating dashboard. It was just 30 minutes of configuration to get all this kind of stuff. So it's interesting when you start taking these different configurable apps together, you can act what seems like a custom app, but really it's just a way to configure the system and a few apps together.
Yes. And Experience Builder, that's our low-code option. So that's one step above all the configurable apps I just mentioned. And Experience Builders empowers you to quickly transform your data into compelling web apps without writing too much code. So you can do drag and drop, and you can also extend the widgets doing custom development related to with Experience Builder. It can create like really immersive web applications. And we have a session dedicated for the Experience Builder, as shown there, and also the Experience Builder Developer Edition just released last year, I believe. And these are also like great options for app development. And the next up is Hub. Let the expert talks about it.
So when we say Developer Edition for Experience Builder, it means you can actually deploy it on your own to your own servers and then deploy your own components into it. Let me just fix that last animation. So ArcGIS Hub is nominally it's a configurable application, but it also is meant to and designed by the name to bring together a lot of the applications. So Hub has a number of different functionality, and we talk about community engagement. The community engagement, though, can be internal. It can be amongst staff. It can be with contractors. It can be with nonprofit collaborators, with the public constituents. It has a full website builder, custom domains, theme and brand it. It can have multiple pages behind it, and I'll show an example how it can embed other apps. It also includes a search engine that's like a curated subset of your organization. And this applies both to ArcGIS Online and ArcGIS Enterprise, there's enterprise sites, which is the exact same thing. And that allows when someone says, okay, cool, I love your branding. I love that you're helping. There's one called Cat Count DC, and they're trying to monitor and maintain all the stray cats around the city. And so that's the website, but inside the data set, we'll be like, well, here's our dashboard, and here's the data set, and here are the survey responses, and here's our upcoming events around this. And Cat Count is part of the Humanitarian Society, has a lot of things going on, but they focus on the cat count versus other humanitarian projects they go. So you end up having hundreds of hub sites for different departments or projects or programs. Both if you're within an agency or you're a contractor delivering things to another agency, you might package that up with a hub. There's also other collaboration. This kind of goes beyond for this session here, but there are other collaboration features for groups and discussions and APIs inside of that. So if you wanted geographic-like chat, Hub has a discussions API as well, and you can hear all about that. I'll have in a second about the details and other engagement tools in these sessions up here. So if you go to these, we'll talk a lot about some of the APIs. But very relevant to this section when you're choosing and bringing apps together is when people build a hub, this is for Hawaii has something called the Aloha Challenge, which is trying to meet the UN Sustainable Development Goals. They wanted a hub site, but with a whole bunch of different metrics. Well, what they did is they actually configured an ArcGIS dashboard, and you can embed that into a hub. This is the Western Libraries wanted a different search gallery experience, and they wanted a geographic exploration of historic maps, and so they did that with an ArcGIS dashboard. Then there's other ones here where they embedded things like a web app builder app, or in this case, an experience builder application, or in this case, ArcGIS Urban. So, and again, so what that means is that Hub is a way in which you might end up building 4 or 5 apps around a program. So here's the dashboard, here's the survey, like the Baltimore one I showed you. You can create a hub site, Baltimore Education, that has both an internal page only staff can view with that survey, and then a public page the public can view with this dashboard. But the hub is the one branded place they can go to and find all those things. So it kind of is meant to bring those things together so they don't have to go and find 15 different apps like you left around, like Lego strewn on the floor, and you actually step on them, which I do with my kids all the time. So developer libraries.
Yes. So developer libraries, that's the right-hand side of all the options we provide. We have a bunch of client technologies available to you to give you maximum flexibilities for customization. But it doesn't necessarily mean it's too much work. Like we have the JavaScript Maps SDK that can help you build powerful web mapping capabilities with comprehensive integration with ArcGIS. And in the lower part,
I'm sorry. Oh yeah, sorry, I'm skipping ahead.
no worries. And like the second, and as we introduced in the plenary session, we're announcing the web components. So these are like easier ways for you to build the fully custom application, but not with too much code. It's going to be so much simpler. Besides that, we have the Calcite design system. It provides a lot of layouts, components, and icons for you to build user-friendly experience using the ArcGIS UI UX. And that's what we use like internally. Like in our applications, we use Calcite ourselves. And of course, we also have open source library support. So if you already have made your investment into open source libraries, we provide a lot of resources to leverage the ArcGIS location service into your open source applications. So first of all, the components. Like we talk about components first at plenary, and I'm going to talk about it first here as well. So first of all, what is components? Components are standard-based encapsulated functionality that are great for collaborations, that are great for working with modern frameworks, and also providing a consistent experience throughout your applications. And web components with them, you can use the components as a simple way as the HTML button to use these kind of encapsulated experience. And why are web components so awesome? Like they are encapsulated functions and styling, so you don't need to worry too much about styling as well. And they're great. They have great usabilities. They're supported by modern browsers. They're standard-based, and these standards are not from Esri, so you can use it in lots of different places. It is framework agnostic. That means if you build a web component and one of your teammates has a web app in React, another teammate has a web app in Angular, it will just work perfectly. You can just fit the component slots, just plug it into both applications. And also, these are great for like developers that are seasoned with framework development, and especially the ones that are coming from a web developer background, not necessarily and web developer background. Sorry. And as an example, it's our Calcite avatar, like how to define it. And so at Esri, we build a lot of web components. These are encapsulated workflows, like the charts, like the effect authoring and label authoring, and we're adding more and more. And these really helps us to increase the cross-team collaboration. And there's so many of them. There's the item browser, there's analysis, the hub, the chart, the symbol styler. And we're thinking like we build all these components, and that really helped us to maximize the shared code and the shared experience. And we should make it available to everyone. So that's why we're having the ArcGIS Maps SDK for JavaScript components that are available for everyone to use. So currently, as introduced at plenary, we have three packages of the components: the maps, charts, and coding components. So the map components are not just the map itself. It's a map, it's a scene component, and there's so many components that has the same functionality or the functionality that are equivalent to existing widgets. So it really opens the door for fast app development. And of course, more and more are coming. And to use map as a web component, on the left, if you have used JavaScript before, this probably look very familiar to you. This is the way we've been promoting for years. You define it, you call the modules, you have the view. But with web component, just this one HTML line passing the item ID of this web map into your application. And the beauty of this is you will still have access to the underlying business logic. So you can build the same application with the same application with the same capabilities. And now you can do it with more productivities using the web components. And the same thing for widgets. Previously, to use the widget, you need to have the view and hook up the widget with the view. But now with the web component, you can just define it with, we can just define here and show with the position you want it to be. And also the web components have access to the underlying JS API, so you can preserve the same business logic underneath. This shows how beautifully simple it is for developers. Either you are like brand new developers that are getting started with this SDK, or like very seasoned, super advanced ones that have been using framework for years. Like web development, web component is the way to go. And for web components, I highly recommend the session here. It's at 4 this evening, talking about like how to get started with it, and we will have great demos to show. And I just talked about the maps component, and here's about the charts. This is a screenshot about the map viewer, so you can author your charting experience in the map viewer, and when you save it, you can bring it with chart component into the web application. And we have so many types available: the scatter plot, box plot, bar charts, there's so many of them. And you can configure the charts in the map viewer and save them in the layer, or you can author them directly in the code. And we have a great session talking about chart components on Wednesday tomorrow. So if you'd like to learn more, feel free to check out.
And this is the place to go ask and see, do they have like double Y axes? And if not, when will you add them? That's like, this is the perfect way to do it in front of an audience.
Yeah. And also, like throughout the years, like people have been asking, like, oh, how do you add charts like to using the JavaScript Maps SDK? Like before the charts component, we don't have anything like built in. Like in our demos, we use like other libraries. But now this is the way, like to just very simply bring in charts and your beautiful visualizations. And also, as I mentioned, it works great. So components works great with the frameworks you're using, either React or Angular or Vue, and this really improves the front-end productivity.
Or even framework-less.
Yes. And also, besides that, we have the Calcite design system. So the Calcite design system is a collection of icons, of color and themes, of these great components you can use to build very beautiful and interactive UIs. And you can apply your own branding, as the planner demo shows. It doesn't need to look like Esri. I've heard that a lot. Like the apps I built looks like too much like Esri. But you can apply your own branding, like your own font, your own size, your own like business color. Like you can just customize it to make it the app yourself. And these are like all of the great examples. And some people may ask, like, what are the difference between like the web components and the Calcite components? Here's a good example. Like the map on the right is a map component, like it has a map in there. And the Calcite components are the layouts, like the upper left corners, like the name of the app. Like that's when we call out Calcite to have the beautiful layout and buttons. And same on the left side, we have the editor component that we use to work on the workflow. And we also use Calcite to create the beautiful hint, like what's the problem, like that's the part we create with Calcite.
I think it's really important to just also think about when you are building your own components. I mean, there's an analogy of the Russian nesting dolls, right? So just be clear, like Calcite is the layout and the design of it. And then we build our like functional or operational components with Calcite and then add a bunch of magic to it. And then you can build your own components. You can do it by, well, I want the web map, but I want to put something else around it, so it's my special component that uses the web map and something else. You can turn that into a component. Or you can say, no, I don't want that functionality. I just want the Calcite shell, but I'm going to wrap it up and put my own magic in it and call that a component. So components, again, encapsulate it both at the Calcite design, which is a design level, and then we add functionality on top of that. And you can too, either using ours or your own. And again, the reason we're putting Calcite out there is because when you do want to build that one little widget, you don't want that to stick out, quote, like a sore thumb and or be programmed differently. It's like, well, I'm going to use Esri stuff that's all 90% there. I need to build my one thing. If you build it with the Calcite design system, and you plug it in, then it's going to look and feel the same as all the rest of it. And then you can, so when you apply your theming once, the Esri components and your components will all get that styling consistently applied to it. So it's going to look great. It's going to be consistent to interact with and very easy for you to maintain.
Right. Yes. And also for Calcite, if you don't want to make a map-centric application, you can just use Calcite itself. Like we have great components like color picker, date picker. It will be a really big pain to like create your own, but like with Calcite, it's all provided to you.
And it's free.
Yes, and it's open code. You can see the code itself like on GitHub. And here I'm going to show a very quick sample about using components. Can you see it?
Mm-hmm.
Yes. So here I have a web map authored. It's about the college scoreboard. Like every single dot represents one college, and we have in the data behind it, we have the how much it costs. Is it private or public school? Like the name of it, the admission rate, etc. And we also have like a few charts authored. Like we save it with a layer. So here I'm creating a very quick application. It's very short, you can see, using Calcite web component and the new chart component. So this part, the upper part, the college scoreboard, the title, is created with the Calcite shell and Calcite navigation. And the chart part is this line, the ArcGIS charts scatter plot. So we just call it in here. And for the map itself, it's using the map component. We define the base layer to be gray, and also the item ID is pointing to the web map item ID. And in the JavaScript part, so we pull the feature layer from the web map, and here this line saying like, wait, feature layer charts number 1. So this is showing the first chart that we authored and we saved in the feature layer. And if we can change it to number 2, I hope it will load soon. Uh-oh, internet, come on. It's taking a little bit long. So here, like the charts 1 or 2 is like calling the charts that you authored in the application. Like here we have a bunch of them. And the previous one.
That's really slow.
Yes. It's like pointing to the distributional cost. And when you're pointing to number 2, it should pull up the bar chart about the count by type. But it's very slow.
So while it's loading, like, so right, it was interesting in your code. Okay, I'll let you go. Then I have a question for you.
You can go ahead.
Oh, so let's say you want to, like, so the way you've coded it, Emily, like, let's say, you know, I'm sure you've never had a manager come in and say, yeah, but I want the reds to be redder, and I don't like that color yellow, and I want the title to be different. And Emily's like, how much code would you have to change to make those changes?
Oh, it's very simple.
0, right?
Yeah.
Because where would you make the change?
So I can just make the change like in here in Map Viewer. And if I want to be crazy, like I can change the title of the feature layer.
Yep, exactly. Just saying that I think that's the key part. Is like as a developer, you're like, I built the application, it's solid, it's tested. If someone wants to go and change things like titles and colors, go nuts. They go and do it in the configurable application. They can make somebody happy. They can do all that things, and you don't have to change your code at all. You're not like last minute before it goes live, making quick changes, and all of a sudden you forget a semicolon, it breaks, and you're blamed. It's like, code solid, it's declarative. Someone else can go in and as much as possible modify and change the layers and the style and things like that, and just it loads up through they refresh with the new web map, and it all just make the manager happy.
Yeah, definitely. Yeah, and also we have the same interactive experience as you can see in Map Viewer. Like we have the tooltip, you can enable them, and also we have the like additional action bar here to do even more interactions. And you can also turn them off if you want just very simple ones. And let's talk about the core JavaScript SDK. So we've been talking about it for a long time, and we're always very proud of it. So the key features, we have very fast performance, and we keep having new and new technologies, and we just do so much work behind the scenes to make sure like we have the best performance. And we are 2D, 3D SDK. There's new 3D effect, and there's great 3D web-based maps and the uploads as you've seen in the plenary. And the client-side analysis, there's so many more happening. The workflows, we have a lot of components. One of the new ones we have is directional D-pad that allow you to navigate when you don't really have access to pan around the map. That's great for like an editing workflow. And also we implemented the drawing with constraints in 2D and 3D. Also about oriented imagery and new, very powerful component/widget such as value pickers that can really help you streamline your workflow. And of course, data-driven visualizations. Like there's so many ways to tell an effective story through your data. And if there's too many of them, we have great ways to consolidate them for aggregation. And we also add more animated support and custom vector symbologies. And these are like a few things we do to make sure like the feature surveys and our performance are fast and everybody's happy about it. And first thing first, feature layers. So feature layers like the core of the APIs. It is so powerful. You can create a truly dynamic experience with your data. And all these beautiful effects and client-side filtering, analysis, all those can be done in feature layer. And also, feature layer is the best marriage between fast performance and also updatability. So every feature, you can update them as we shown in the editing capabilities. And also, it loads super fast. So you don't have to choose. Like these two are provided for you. And also for the feature layers, we are the one working on the feature service, so we make sure it is fast. We hosted it, so you don't need to worry too much about the speed of loading. And besides feature layer, we also provide support for all these kinds. There's an OGC standard, the CSVs, or GeoJSON. And our code is very simple and also very similar for all type of layers. So if you have a GeoJSON layer and one time you swap them out for a feature layer, you can just change the class, change from GeoJSON layer to feature layer, and you will open up so much more like capabilities and better performance. Same for imagery layer. And for the data-driven visualization, there's different styles you can do. We have effects, we have the smart mapping, we have the visual variables, all for you to create beautiful visualizations. And of course, like we have a lot of cartographic techniques, like blending effects. The upper left corner is a new one in 3D. With the custom node, you can have a zooming effect, making everything very small and cute and focused. And also, of course, for 2D, like you can combine the power of blending and effect to create really beautiful and engaging applications. And again, like web map is the center here, web map and web scenes. When you have them authored, you can save them as web map or save them in the layer level, and then bring it into your custom web application.
And the web map viewer is also nice because, again, it's just really just a visual editor for editing JSON. You think of that, just a really pretty JSON editor. So what I mean is you can check out what it's doing when it changes these properties, and if you want to make that programmatic in your application, well, this is a way to play with it and say, okay, I see what it's changing, I see how that works. Now I know which parameter I need to toggle or jiggle in my code that's going to modify the web map JSON, or through the JavaScript SDK. So just you have full control in your programmatic to do everything the web map viewer is doing.
And also, you can just override what you have in the web map. Like your colleague created a web map, but you're not 100% happy with one of the style. You can just override it. Like, yeah, like just drop their highlight where their drop shadow.
You're saying developers have ultimate veto power?
Yeah. And like the code for bringing the web map is very simple. If you want to use it with the core API. And again, we're 2D, 3D API. For the 3D part, we have a lot of beautiful visualization effects and also great analysis. You can show like the elevation profile. You can create analysis on. You can create analysis on all different kind of buildings. So these are just great ways to represent your data. And we're also really proud of the feature side processing. That means working with your features. It means querying, it means statistics, filtering, and geometry. So in this application, you can see how fast everything is going. So what it does is a geometry, querying by geometry around the mouse. When we mouse over, it just quickly do the statistics around the data set to generate charts and generate the numbers in the upper right corner. And you can do that in 3D as well. So the client-side processing really enables for you to build extremely interactive experiences. And also the thing about client-side, when you're doing these kind of analysis, there's no data sending through the server. So if you have a big data set and you're doing a lot of querying, it can very easily jam up the server with too many requests. But with client-side, everything is happening in the memory in your browser. So this way it can really enable you to build interactive applications. And it's not just for vectors. We support client-side processing for rasters as well. And we create functions, and we're adding more and more raster functions as well. It's for visualization analysis in the imagery. And since it's Developer Summit, and we offer so many sessions about the JavaScript Maps SDK, and on the upper right corner is a blog about a guide to web developers. It talks about session recommendations for framework builders, for people who want to use Calcite, for advanced users that want to take their apps into the next step, and also for the newbies that want to know more about JavaScript. And there's a list of some recommended sessions besides the component ones and Calcite ones we have talked before. And besides our full-featured JavaScript Maps SDK, we also have resources for supporting the open source APIs. So I know some of you have already made some investment into the open source mapping libraries, and we definitely support you to use them. And you can bring the ArcGIS location services with them, and we have a great samples, guides, and documentations for integration with Leaflet, OpenLayers, MapLibre, and Cesium, and that's the latest edition. And there's a lot you can do, but there's also considerations for the open source libraries. We always recommend, if you want to unleash the full power, use our full-featured JavaScript Maps SDK. But if you have already made your investment, or as Andrew said, if your organization makes you to use one of the open source one, we definitely support you to use them. And you can bring the Esri ArcGIS demographics, location services seamlessly into your application. So back to you, Andrew.
Whew, okay. We're going to get into the data mines now. So should we skip ahead to that one? So yeah, in our short time, we're going to go in deep with some deep technology. So it's definitely going to be kind of, again, a survey of what's to think about, and you're going to go into those sessions to learn more. So first on thinking about data to layers, right? This is the first thing. You have data that's on your a file. It's in a database maybe. You want to turn those into what we call layers. And there's a couple different ways to do that. So if you use our technology in online or in ArcGIS Enterprise, you can load it in via drag and drop the file. You can use our APIs to push it in. We have connectors to pull it in as well. Now, you can do that. The terminology, right? Some of you might know this, but just important for you to understand as you talk about terminology, especially like me, if you don't even come from the GIS world, you're like, you lost me at tiles and raster and things like that, right? But the things to think about are, features are locations, like your records in your database. Imagery is raster, so different ways to store that, but essentially lots of pixels and values, overly simply stated. And then those can be available either as different data serializations and also different ways that we do a lot of work to try and give you different ways you can optimize it. And really, this is where it gets really dependent on the data, what the right optimization is. If it's high density point data or it's sparse point data, if it's line data, if it's utility data, if it's polygon data, it's dense, it depends when you want to do things like different vector tiles, raster tiles, and scene tiles. But these are a quick survey of those. Looking at feature layers, so again, these are like these vector like records that I want to get from my database and put them onto a map or a chart or a table or something, right? So what we do with these is we do a lot of work in our storage and presentation of them to fetch them out in different ways. So via JSON serialization or proto buffers and vector tiles and things like that. You can dive in more to know about even within those different, within the sessions, we'll have links for the different trade-offs in performance and rendering, and sometimes you have to pre-cache them as well to do those kinds of things. The nice thing is they can be updatable, right? So they might get, quote, cached in a CDN, content distribution network at the edge, but you can update those. But that at least makes sure that when people are viewing them at a very, very high rate, they're getting this cached tile of that data's vectors so that when they can render those, they can do all the interaction, but they're not coming necessarily back even to your database until there's an update to those things, so which is really good. And then all of these feature layers is what supports, as Emily said, is these data-driven styling. So all the amazing things she showed, we've built that into our APIs and the way we encode the data and send it out to make that possible there. And so, yeah, as I mentioned before, you can start with like GeoJSON spreadsheets, data formats. Again, there's I think like 50 or 60 at least formats that we can ingest and pipe through the system and through these feature services. I'm not going to go through all this, especially in our time, but just to say it's meant to be high performance, right? So these things are meant to be handled. I don't even know the numbers of these, but like tens of thousands, millions of queries per second or higher. There's different ways you can scale those up that we can scale them up for you, especially within ArcGIS Online with our hosted services. We automatically scale those, and there's no, if it's used once or it's used a billion times, there's like no price difference to you. It's like the credits in online are entirely for the volume of the data, so you can plan that, that. And if something goes viral, that's our responsibility to make sure it stays up and it's available. You can definitely deploy that on your own in server, but then you got to make sure you scale your servers and stuff up and down dynamically as necessary. So, that's, again, there's a lot of things we do to do that via performance and also accomplish open standards and stay up to date. So we deploy regularly to keep those things not just alive and secure, but also add new features to them constantly. And then as last mentioned here, is there's ways to upgrade to premium stores. If you really have big data that's actually needs to be requested more often and maybe updated more often, so caching's harder because it's like semi-real-time data, we have different ways to scale up the premium data stores. So just again, kind of from a performance perspective, this is just showing on the left loading data via just a straight GeoJSON, which GeoJSON's great. I love GeoJSON. But my gosh, it's not necessarily the most performant thing, especially at scale, because it's really just one big file. It doesn't really have pagination, doesn't have protobufs, all these things. On the right is feature services, which can do pagination, tiling, all kinds of things. Our SDKs and libraries and that we implement they figure out which one to use when, and you can tune that as well on your own. So this is kind of just a lot of performance benefits by piping them through and using feature services. So that's just like your data out there. But I also want to talk about there's a lot of other services you can use at your fingertips, or you can publish your own that I want to highlight as well. So we have a number of what we call like these location services. So you might think of, we've talked about the base maps, right? But there's like geocoding, like addresses, and you can build your own locators that use your own data. So I live in Washington, D.C. There's a lot of different names that don't show up in the national ones. So they have one that works for theirs that have facilities, and it's an open API that you can publish your own geocoding service, routing services that aren't just, how do I get to target, but I have a 15-ton truck and I have this height restriction and I can only go along these routes, and you can create and publish your own routing services or use ours. And there's a bunch of other ones for spatial analysis, hydrology, elevation, you heard more and more. So those are all there at your fingertips. They're all RESTful JSON APIs, super easy to use, just natively in whatever language you want. But also you can use obviously our libraries and SDKs and Python and .NET and Java and Rust and all these other ones to access those because it's just easier. When you do want to make your own, we have a lot of base maps off the shelf, and other people make base maps that are there, which again, they take all this amazing data and say, I've made it look really good for you to help understand the context. But you can make your own. So we have a vector style editor that was just recently updated, I think, with a lot of new features that you can go and like change what you want your highways to look like. Or I'm a bicyclist, so make those roads dangerous and make the bike lanes beautiful, because that's how I get around. You could do that kind of thing, depending on what your use case is and having multiple of those. So vector styles, you can just in the editor change all the colors and styles at different levels, publish that, and that can get reused in all the different web maps that your organization or anyone in the world that you want to share it with can reuse as well. So again, you can make your own, again, extending. And then the last thing I'll make here for the last of our survey is you probably have data in your APIs you're integrating with on your own. In the past, it's like it could be things like Zillow or Craigslist, or it could be a custom payment transaction database or a healthcare database, things that data can never leave that system, at least wholesale, can only be accessed with keys. So what we want to make sure is that you can easily access that data via different custom APIs. And the one way we have to do this is a project called Coop. It's this little over here on the side. So Coop.js is an open source node-based framework that you can build and deploy your own servers that can tie into whatever backend API you want to, with a few lines of code for what we call a Coop provider. So again, you can find videos and we can share with you afterwards, like literally someone is making a web map in ArcGIS Online comparing Craigslist listings to Zillow to open table reservations to weather data, all live, talking to those live APIs using Coop as the back end to get it back into the rest of the system. Because again, they wanted to use all the rest of the stack and configurable apps, but they wanted to extend and customize just that API. You can also do the same thing on the other side. If you have data from an ArcGIS server or a feature service or GeoJSON and you want to make it look like something else, you can also use Coop on the other side as well. So we kind of think of it as this great babble fish for the web in a way. So Coop is good, but you will have to deploy it on your own servers. Now, Coop is also available as custom data feeds in Enterprise. So if you are running Enterprise, you need to connect in like a Snowflake database or something else, go find out about the custom data feeds. Then that's the same technology behind the scenes that you deploy through Enterprise, which is good because then above that, all your users are just working with items that are layers, and they get to use configurable apps and story maps and everything that we've talked about so far. So pretty flexible, and there's a session all about that on Thursday. And, this is the example I mentioned before. It was just one example pulling together data from different services that obviously Yelp is not going to necessarily deploy. Well, actually they do, but that's beside the point. ArcGIS Server behind the scenes, but for their API, they have their own API. Coop is the way to translate that. So that brings us now to wrap up in our overture of Dev Summit and the ArcGIS platform. Just to reiterate what we said at the beginning, is that you can think of this as good web architectures have multi-tiered structures, right? So you have your data, you access those through libraries, you have components that are built in part of those libraries, and then you use those in applications. And by following this pattern, you can get going really fast. As I mentioned, in less than 5 minutes, you're building applications, you're getting that out, you're solving problems, you're helping people, you're growing your business. And then as you go with that configurable app, you can bring in new data on the back end, or you can modify one little component, or you can change the style and build charts there, and you can even progressively build your app out. So depending on where you find your business or user need is, or your drive is, you can choose to extend at any level here by following this pattern, which is why we wanted to highlight this to you here in this session, so that you go and learn about technologies, you can frame that one little amazing superpower you just gained, but plug it back into a system that lets you not worry about the rest of it, because you want to focus on your unique problem you're solving, your unique ingenuity, and focus on that and have the rest just taken care of for you, and call us if something breaks, because that's what we want to do for you. So with that, here's a summary of, this might be the old slide. Do you have the new slide for the sessions? So I'm going to switch back to Emily's. So you're going to want to take a photo of this if you want us to help set your schedule for the rest of the week. I think. Sorry about that. Oh, it was the right one. Okay, cool. So so this is the summary of what we covered. Is there one for sessions? Okay. Just for time, we're running out of time. I guess I'll skip this. I mentioned all this. I'll do this. Oh, no. So, so I hope what we did is we're inspiring you. Again, we show all these sessions when people build these maps. I mean, be honest, when you do the plenaries, like they have spent, as they said, weeks, and Jack said years. Someone's getting to this point, right? They looked slick and easy. They actually are pretty easy, but it's going to take, we're going to try to show you the best of what's possible, and now you're going to go back in your data, you're like, my data's not quite there yet, but I know it's possible. And we're going to inspire you to do these things so you know it is possible with the technology you have now at your fingertips, and everyone in the world does. So we've just showed you how it all works, how you can put them together, and given you lens to see the system through. So I'm excited to see you be creative with it. I'd love to see at any point right now, through the week, in the future, what have you built? What have you tried? What have you done? What are you going to be showing at the UC plenary stage or Dev Summit stage in future years, like you saw this morning? So thank you very much for your time. This is feedback for our session. We'd love to know, because this session is meant to get you started for the week. So give us feedback now. If you want to come back later and say, oh my gosh, that idea you had, now I get why. We'd love to hear it. We look at and read every single one of the feedbacks that are there. So that's a hugely important to us. And do you have a summary of all the sessions or no? Oh, we don't. OK, sorry. So with that, I think we're going to close up here. So again, thank you very much for your time. We're at time right now, but Emily and I can hang out for a little bit and answer the questions, some of which thank you for those offering beforehand, as well as I'm sure maybe sparked up some new ones. And I hope you have a great rest of your Dev Summit. Thank you.
Thank you.